the attendees mostly muted for the presentation, there is a questions pane in which you can type in text questions, and if you come up with questions during the presentation, I'll try to take a couple minutes at the end to address them. So today we're going to introduce TREAT. We are going to model a single-family building. We'll take a look at the California modeling guidelines, and we'll point out how to get help with TREAT for getting started. TREAT stands for Targeted Residential Energy Analysis Tool. It is a whole house building model. You can actually use TREAT to do all kinds of buildings, not just single family. And in all cases, we really look at the whole house. We want to model the thermal envelope, essentially, a lot of the time. It's an hourly simulation tool, so TREAT does 8,760 load calculations in a year. So on the analysis end, it's got quite a bit going on. Interactive improvements and packages, this is like the whole reason to use energy modeling software, to understand how the various improvements that you want to analyze impact each other and impact the building. TREAT has integrated billing analysis and true-up. It's an optional way to increase the accuracy of the model. And there's other information can be stored in TREAT. Various aspects of health and safety data can be stored in, and lots of different reporting options, which give a lot of flexibility. What we're going to focus on today is rapidly modeling a single-family building using the new building wizard, one of the two paths to create a TREAT model. Any house is a system. We all know that as building science related people. And what we've seen is that a lot of modeling tools will just deal with some aspects of the house, or think about different aspects of the house in different ways. And in TREAT, it's all, and a lot of energy modeling tools, of course, it's all wrapped together. The number of people in the space and the hours of operation of an appliance and the wattage of the lights all comes together to impact the heating load and other energy details. Interactive saving. So probably everybody on this webinar today could build a spreadsheet that says how much we could save for a lighting improvement and approximately how much we could save by increasing the efficiency of our heating plants. And one-off calculations, or generally even surface insulation improvements, can be calculated by hand or by spreadsheet. That's easy for the human brain, but where it gets difficult is when all these things come together, and I've got multiple window and efficiency and hot water improvements all coming together, and I want to know how are they going to behave when they are all working together. And that is essentially the package of TREAT. TREAT modeling, we like to start getting organized before we enter the software. So we take a look at the building that we have and we reduce it down to a simple understanding of the geometry. We want to know about the size of spaces and walls and square footage of windows and things along those lines. We want to understand what we're going to need for the heating systems, capacities, efficiencies, probably distribution system details. We'll have some understanding or defaults for the behavior of the building, how many people, how many hours a day. And of course, the reason we're all here is you want to have an idea of your improvements before you start building your model is the best way to do it, because then you can have a really strategic, focused model and not spend a lot of effort developing unimportant aspects. So we are going to walk through a single-family building together, but I just want to point out that if you Google PSD Consulting California Modeling, go to psdconsulting.com/California, or even get it from probably Energy Upgrade California, This is a great document to be aware of for getting started. So this is the California Modeling Guidelines document, and you will see it's got helpful defaults. Sides of is that we don't always have really solid data. You know, a lot of engineers have trouble with that. I think that some stuff we know and some stuff we have to accept as a rough estimate or unknown. These values are to use when you don't know. For instance, that the domestic hot water temperature is not available, or how much hot water the building uses is not available. You know, here's some good defaults that you can target your model towards. A lot of information in here, so please do look through that. Okay, so we are going to quickly walk through how easy it is to build a simple home in Treat using the wizard. So I have just selected a sort of typical two-story slab-on-grade vented house for us to model. And in this case, the garage is detached and not heated. So we are just going to model the freestanding house. Here's the basic details that I've gotten from my auditor about this house. 2 stories, 2 bedrooms, 3 occupants. Here's the footprint. Like we said, it's slab on grade with a vented attic. There are fiberglass bats in the walls, an uninsulated attic, an older furnace, and we did do a blower door test and looked up some information on the hot water heater. And this is, you know, once I've got all the geometry, I can build a pretty solid treat model with just this much information. Okay, so let's switch over to treat. Now a treat file can actually have multiple models in it if I want it to. I don't typically use it that way, but that's why I'm going to say project group and then new. Start new building wizard or create blank project. And if I am doing a single family model, I almost always will want to do the start new building wizard. What I do like to make sure people understand is that after I finish the wizard, I go into detailed edit mode. I have the opportunity to change everything that I picked in the wizard. So at no point am I reaching like a point of no return. The TMY3 weather site is what I'm going to want to select. TMY stands for typical meteorological year. This is the weather file that's actually used to run the model to generate the energy results. And I always want to pick TMY3. That's the more recent average weather. I have a 2-story house. It had 2 bedrooms with 3 occupants. Medium walls with the dark roof. My foundation was a slab on grade. But notice I can pick conditioned basement, unconditioned basement, vented crawl space, unvented crawl space. There's a lot of flexibility here. And depending on what I pick, it'll ask me a depth below grade if I do have a below grade space. And that's so it can actually create above grade and below grade walls for that basement. Just demo some of the other features as I go. So we have a slab on grade foundation and a vented attic. Air leakage in treat can be specified in ACH natural, that's air changes per hour, often between 0.5 and 1. And when the data is available, CFM 50. And this building got a score of 3,000 CFM 50, which of course means cubic feet per minute at a 50 Pascal pressure difference. I could have, by default, gas or electricity are available in the wizard, but that can always be customized. Okay, so now conditioned space walls adjacent to the outside. So I'm looking for 2x4 walls with fiberglass bats. if I click here, I do get some quick options that I could pick, sort of a quick select feature. And the selections in this dropdown are user editable. So these can be your most common surfaces to speed up a lot of using trait focuses on efficient modeling. Otherwise, I go into the surface library. I filter for wood 2x4. I filter for a fiberglass bat, and I have a lot of options. In Treat, you don't build custom assemblies. You pick from what's available in the library. And it's always good to keep in mind what's important as an energy modeler here. If I am looking for a wood-framed wall of a, so this frame, I should say, goes to inform heat capacity, how much heat the structure can hold. And then, of course, the R value, how quickly heat moves through the structure. And if I feel good about my R value and my frame, I'm not as worried about the English description. I know that heat capacity and R value are really the important parts of the energy model. So anything in here would probably be good. It's always good to have a description that does seem accurate. So gypsum board with fiberglass filled cavities with wood cladding, that seems like a good option for this model. Now I'm looking for the conditioned space ceiling adjacent to vented attic. So I'll go into the library again. I'll know that my ceiling is framed out of 2x6 or 2x8, or, you know, the sky's the limit with buildings, of course. And that was an uninsulated. And I want to be careful to understand that no insulation implies an open cavity. An air insulation means a closed cavity, an actual pocket of air. So I'm looking for probably some kind of gypsum board finished open cavity surface adjacent to my attic. So I'll pick this one. Now, conditioned space floor adjacent to ground, I have to make sure I remember what basement type I modeled. So in this case, this is a slab on grade. Perhaps it is 6-inch concrete. It may or may not pick carpet with pad. Foundation walls and floors adjacent to ground are not, unconditioned floors adjacent to ground are not included in this model. And the windows are clear glass with wood vinyl operable frames. And I do have glazing and framing libraries I can look through if I want more options, just like the surfaces. Okay, so these are the basic construction details of my model. Now I have the opportunity to define the geometry. I have a number of shapes I can select from, and these shapes are of inputs I can use to create a building. Our building's a nice rectangle measuring 38 by 29. Now B here references the B in this drawing, and I use this drop down to control the initial orientation of the model. So as this is just set up right now, my short sides of my house face north and south. I always have the option to rotate a treat model, so it's not the end of the world if I misinterpret it now. I specified the size and type of windows on the last screen, and now I am just specifying window counts. And very important to note, this is a 2-story building. We are only specifying right now details regarding the first floor. Okay, so when I click next, now it's the second floor. This actually, it defaults to be the same, so I don't have to waste time doing identical data input, but this adds a lot of flexibility for when you have houses where this, maybe the first floor is larger than the second floor because of additions or the design of the building, or sometimes the second floor has a bigger footprint than the first floor, and I have to account for like cantilevered floors. Either way, this lets me have different footprints for each story. These space types are a set of defaults that I can choose to have generate typical lighting and typical appliances. The lighting and appliances that are generated are user customizable, so I can get that set up to do exactly what I want it to do. And again, I always have the option of going in and changing things once I get into the model. So that is the end of the wizard, and I can click Finish. Okay, and now this is the basic treat screen. Treat is basically broken up into 3 sections. On the left is the project index, and this is like a navigation bar. I can use this to move from screen to screen. In the upper right, the data input pane, this is primarily how I interact with the results. A screen with a question mark indicates that the information has been populated on that screen. So all of these question marks show what the wizard has done for us. Nothing on this screen is going to influence energy modeling details, but just to show you. Now, prepared by, my name is Alex Lavallo again, is already there available to me. And this is an example of the treat editable libraries. Also, I have, well, some old fake customers available. So I can, for some of the inputs in treat, build my own personal time. I do not need to select the city I live in every time I build a model. There's a lot of opportunities to customize for time savings. On the fuels rate screen, I want to see everything that is available in my model, but I can see that's, unless I want more than natural gas and electricity, that's checked off. So what more do I need to do to get this model to run? I need a heating system, a natural gas furnace. I believe that was measured at a 78 AFUE. Oops. My capacity is in BTUs per hour, of course. The location of the heating system specifies some of the defaults for what spaces the distribution is running through. Currently half in the first and second floor, but I can customize that, of course. My hot water, gas storage, hot water, and we'll make it a small 40-gallon tank. Specify the supply temperature. I can customize the hot water distribution I choose. And that actually, for the most basic model energy results now. Model heating system, and actually that's it. A hot water system is optional, but we did add that. Now I've got my base model, and I would want to review spaces and surfaces to have confidence in what the wizard created and make sure that I agree with it. So I have a first floor and a slab on grade. I'm just, mentally checking that there's a complete envelope. A second floor with 4 walls and a ceiling to an attic, and an attic space with 2 roof surfaces. Adding improvements to the models can also be very quick. If I wanted a new furnace, there is a furnace improvement. And add a new dishwasher from the appliance library. Maybe I've got a new Energy Star high efficiency model. Customize how many loads per week I'm running. 5 different prices. That's fine on the improvement screen. It's on the packages screen that I can only have one, such as a set of improvements that will provide X energy savings. And up here are the initial treat feedback. So millions of BTUs. And it gives me usage of the model after the savings from this package, and then I'm sure people are familiar with payback period and SIR, which is savings to investment ratio, which for a good package I would want to be over 1.0 generally. Okay. That's as simple as it can be. I'd like to point out California collecting some data through visual inspections. So I could, for instance, enter in any of this information and together to build the submittals to California. So we'll be communicating with HPXML file. Generate on the report screen, I have a lot of different, some of them are sales tools. We'll take a look at one of those. The home performance report, for instance. I do customer facing package. Sorry. Report we'll see. You can see lots of nice formatting, feedback, customer sort of style, building science communication here. There are more technical reports. I'm going to have some questions. So after, I should show that you can download the treat demo at psdconsulting.com. Total the website where to treats up to Nate and I. So a good way to go if you're having trouble. And that's so that is modeling and building in improvements that I want. I'm gonna. What are the sources for the defaults? Asks Charles. They are varied, I would say. They're a combination of defaults from outside sources, a variety of them, combined with sort of best practices and recommendations by comparing models that have been built to real California buildings. And if you had more specific questions about that, I'd be happy to address them through treat support. Do you automatically add the rim joist height in a 2-story building? So if I had a basement with a treatable rim joist, then I would want to add that in manually. And to show you, if we pretended, for instance, that this first floor was really a basement, I could copy these walls and make them 1 foot, copy, paste, 1 foot. You know, I'd probably change the construction a little bit to be more like a rim joist, but and so I could very quickly add 1 foot tall wall sections all the way around the building. There, I'm done now. There's my rim joist that I can build a surface insulation improvement. Maybe I want to decrease this 8 feet to 7 feet to account for what I've done. Whatever is real. Good. Can you fuel switch HVAC? Yes, absolutely. Or water heaters or anything. Yeah, so any fuel that I want to model, for some inexplicable reason, propane is not, I will add it. And the only important detail is from a natural gas furnace, a propane steam boiler. That's probably pretty rare in California, right? We should do. And then since I'm switching to hydronic, I need to define my new distribution system details. So I could do the same thing for hot water as well. There's a question about treat defaults versus some other sources of California defaults. And so my universal answer to those questions is ask the program. Definitely ask the program. They can give you the most up-to-date and accurate information on what inputs they want you to use. The treat defaults, I should say, aren't it is a separate document. You know, they're not automatically entered into the software, though, Charles. There's a question about, can you model additions? So as an improvement, not really. In my base model, I can add additions. Like I can add more on to the building that was built in the wizard. As an energy modeler, I don't often need to model additions because they are always negative, except for maybe some super extreme case. Increasing the volume and surface area of a building doesn't provide energy savings. So I can see why it might be useful to see how much extra energy the customer is going to waste, or use, I should say, but it's probably not an effective sales tool. Griffin asks about the loads report, so let's ask a question about that. Or sorry, take a look at that. The loads report, oops, I need to room or space by space or model. At the model level, it's at the space level. It's going to automatically spaces when you're making your model. There's a question about LED lighting. So lighting is very freeform. Oops, that's appliances. A light wants per day, and there are this many of them. At a large lighting load, if you're using utility bills, that would be. Can you run a HERS rating? Treat used to do that and no longer does provide HERS ratings. Can you use a two-model simulation to model additions and determine the energy savings? Absolutely. I've mostly been trying to focus on a one model. I'm working in California and submitting this to my program. But once you start to think a little bit creatively about multiple models, then yeah, you can model almost anything you want. So if I saved this model and then I saved a second copy of it and added my addition, my 5,000 square foot addition, now I can compare the results of these two different models and see how much that's going to increase my HVAC consumption. Good question, thank you. A question about tiered billing, or do you have to enter in an average cost per kilowatt hour? Treat does not include tiered billing, but that's a good question because that's, besides tiered billing, that's a question through our whole industry. What number do I put in for my energy cost per unit? And there's more answers than that than you would expect. If I just divide my total kilowatt hours on my electric bill with my total dollars on my electric bill, I get what we would call a blended rate. And that blended rate is incorporating all kinds of fixed fees and charges and taxes, which don't have anything to do with how much electricity I use. If I separated out just the stuff that is reactive to how many kilowatt hours I consume, just those line dollar items, then I have a marginal utility rate. If I do have tiered billing, I am going to enter in the price for the tier that I am saving energy in. So say for my first, and the California tiering is like backwards and very confusing to us New York State people. If I have two tiers though, and I know that I am going to save energy in the second tier, I am going to use the second tier pricing. This is another one that would be good if this model is for a program to ask the program. Okay, and our last question here has to do with pool pumps, but we'll use it to talk about appliances in general. So I can, in my appliance library, select a pool pump and add it to the model. But I am making, an assumption that this kilowatt hours number is accurate for the pool pump in question. And probably my pool pump's on the exterior of the building there. So that is one way to do it. But I can also, if I have measured the pool pump or manufacturer's information, I can make a custom appliance, which is a pool pump, and have it use as much electricity as I would like. And on the flip side, I can add a appliance replacement, the old pump from the model, and add a model of new pump, which uses less electricity, hopefully. And so that is a pool pump and a pool pump replacement. Oops, I created that new space. So thank you all very much for joining out again. That you can get a start at PSD training. And I'm now going to turn things over to my colleague Nathaniel.
Hi everybody. Alex, can you just scroll down to the next slide? Thanks. So thanks for joining us. As Alex said, the best place to get started with Treat is to visit psdconsulting.com/California. You don't have to write that link down. We will be sending information out to all of you, so no rush there. That page has all the information we talked about today. It contains the California modeling guide. It also, most importantly, has pricing information and lets you order Treat if you're interested in getting a full version. In California, we offer a 6-hour online Treat training course at a reduced rate for folks who also purchase a Treat license for the program. So usually a Treat license on its own is $495. When you buy a training seat in conjunction with that, you save $100, $799 total. Gets you 6-hour training. That's also worth 6 BPI CEUs and really gets you a top to bottom with Treat. It's also important to note that the pricing structure for Treat is a bit different than some of the other tools available in the program. With Treat, you purchase it one time and then it's yours to own indefinitely. So $495 per user, per computer, and that's it. There's an optional fee after the first year if you want to maintain customer support, so the ability to ask Alex and myself questions. That fee also covers any free software upgrades. So if you don't pay that $200 fee, you miss out on those things, but it's certainly not a requirement. Thanks so much for coming. We will look forward to hearing back from you, and we'll be sharing a recording of this video and also a little bit of information with you shortly.
All right, have a great weekend, California.